Okay, today we will learn on the part 3, okay, of this topic, and the focus is on the software testing process. Okay, so this is the process in the software testing. Okay, so we start with design the test case, and we produce the test cases. We prepare the test data, okay, and we come up with the test data. We try, and next process is we will run the program with the test data, and we get the test result, okay, whether it is the output that we get is as what we expect or not. Okay, then we compare, okay, and we come up with the test report. Okay, so you can see this figure. We have all the processes now. Start from the designing the test cases, test data, test result, and test report. Okay, so test cases. Okay, here are we have three approaches. Okay, in designing test cases. Okay, the first one is requirement based. Second is black box, and the third one is white box. So all of these, okay, are three approaches, okay, in designing a test case. Okay, so what we do in test case design is we design, okay, the input and output, okay, used in the system, okay, when we want to test the system. So the goal of test case is to create a set of tests that are effective, okay, in validation and also to defect testing. Okay, so these are the approaches just now. Okay, okay, so now we go to the first one, which is requirement based testing. Okay, if we recap to the our discussion during the requirement engineering, okay, topic, okay, there is a general principle, okay, of requirement engineering is that each requirement should be testable. Okay, so requirement based testing is a validation testing technique, okay, where you consider each requirement and derive a set of tests, okay, for that requirement. Okay, so from the requirement you get the generate the test requirement, and then generate the test cases, and then we generate the test flows. Yeah, so this is the example of requirements. Okay, we have for example, this one is for library system. Okay, so the user shall be able to search either all of the initial set of database or select a subset from it. Okay, so now we focus on the first requirement here, which is search. Okay, so so in this okay, the requirement here is, okay, to initiate user search, okay, for user search for searches for items that are known to be present and known not to be present, where the set of databases includes one database. Okay. Uh, Second requirement is to initiate user searches for items that are known to be present and known not to be present, okay, where the set of databases includes two databases, and so on. So these are all the criteria, sorry, they're all the requirements, okay, that are needed um, to be tested, okay, in order to make sure that the search function just now is valid. Okay, so okay, this is example. Okay, this example for ATM. Okay, so the ATM system must allow the customer to do withdrawal transaction, which each withdrawal is allowed only between 10 to 300 ringgit, and in 10 ringgit multiple. So this is the requirement. So what we have to do is first we derive the test requirements, the TR, okay, test requirements, and choose one test requirement, then derive a set of test cases. Okay, so basically this is the template, okay, for us to prepare. Okay, so we have the case number, okay, the case, test case, what is the data entered, okay, the value that will be entered, what is the expected result, what is the actual result, and whether it is pass or fail. So what is pass or fail? Uh, so during the when you designing the test case, so you will left this empty, okay. uh, this will be because we don't execute the testing yet, so we don't know, okay, whether it is pass or fail. Okay, so okay, these columns are filled in as the tests are executed. Okay, so what is pass? Okay, pass when the uh, expected, okay, expected result and the actual result is same. Okay, means that this test is pass. Okay, but if it is different, means that it is the function is not validate. Okay, because what do we expect and what the actual result, okay, during the test is different. Okay, so it means it is failed. Right. So from there, okay, this is the test requirement that we get, okay, from the ATMs now. Okay, so what we will validate, okay, first is we'll validate that the withdrawal are greater than 300 and less than 100 is not allowed. Okay, validate that the withdrawal of multiple 10 ringgit, okay, between 10 ringgit to 300 ringgit can be done, and so on. So all these are, okay, the scenario, okay, the you can say that these are all the cases of scenario that can be happen, okay, during the withdrawal process, okay, at the ATM. Okay, so this is the test cases, okay, this now the table we prepare. So for example, case 1, okay, withdrawal 01, okay, you just give a code or the ID, okay, for the case. Okay, so the input will be 10 ringgit. What do we expect? Okay, we expect 10 ringgit will be withdrawn. Okay, the actual result, okay, we don't know, okay, until we execute. Okay, and for all, okay, 20 ringgit, 30 ringgit, up to 300 ringgit. Okay, this for this case. Okay, and for uh, case 31, okay, if you enter 301, okay, 301, so what we expect is error display. Okay, and what you get for actual result is the same. Okay, if you get actual in your actual result you get error display, so what uh, this test can be considered, okay, whether it is pass or fail. Okay, if it is same, okay, means that the actual result also error display. Okay, so it means that the test is pass, okay, because the same as what we expect. All right, so this is then from the test cases just now, okay, that we identified, then we prepare the test flow or procedure. I mean the script of your test. Okay, so you can do it like this manually or think automated. Okay, so start from the insert card, enter pin, select withdraw option, and also each of these flow procedure, okay, you will follow. Okay, so this is your test flow. Okay, based on the requirements that you already test requirements that you already designed just now. Okay, all right. So that for requirement based, okay, approach. Okay, we go to the next approach, which is black box. Okay, black box. So in black box, we have two technique, which is equivalence partitioning (AP) EP or BVA, boundary value analysis. Okay, so why we call it black box? Okay, why? Okay, so black box is also called as a functional testing and behavioral testing. Okay, so we focus on determining whether or not the program does what it is supposed to do, okay, based on its functional requirements. So here the tester, okay, he will ignore the internal mechanism, okay, what is happening inside a function, okay, the control structure, the data, and so on. Um, uh, the programming aspect of the function, okay. So at this in this testing, okay, the tester is not interested on that. Okay, what he want to test is whatever you, okay, the input, okay, input, and let the black box do the work, okay, the executable program, okay, do the work, and we check the output. Okay, so it takes into account only the input and output of the software without any regard to the internal code of the program. So that's why we call it as black box test. Okay, so we have two strategies here, which is EP, okay, equivalence partitioning, and boundary value analysis. Okay, so equivalence partitioning. Okay, if you remember just now, okay, for our okay, this is our ATM just now. Okay, here you have to for value of 10 ringgit to 300 ringgit, so you have to prepare or you have to test for 30. Okay, plus 1 here is 31. Okay, test case, and you have to test each of these. Okay, so how if the value is bigger, 1,000, 2,000? Do we have to uh, uh, for each single value of that? Okay, so it is not practical. Okay, so uh, in equivalence partitioning, okay, in equivalence partitioning, what we the mission is to reduce the number of test cases. Okay, we want to reduce the number of test cases. How? Okay, by dividing, okay, the input domain of a program into classes. Okay, into class. So for each of these equivalence class, okay, the set of data should be treated, okay, the same by the module and the test, and should produce the same answer. Means that um, when we have we divide the input into classes, so uh, this all the data, okay, in the same class, okay, will be treated the same, okay, by the, okay, by the module that you are, or the program that you are testing. Okay, so okay, equivalence classes, okay, can be defined, okay, as, okay, if an input condition, okay, specifies a range or a specific value. A range means that a range of number, a range of what we call alphabet or values, okay, or a specific value. So we can derive one valid input, okay, and sorry, this is, I think this is, okay, it's supposed to be one valid and two invalid. Okay, it's supposed to get one valid class and two invalid class. Okay, whereby an input condition, okay, specifies a boolean, okay, a boolean or a member of a set. Okay, so you can get one valid class and one invalid class. Okay, so for example, okay, this is a specification, okay, for a database product. State that the product must be able to handle any number of records from 1 through, okay, 16,383. Okay, so here the valid data should be from the range is from 1 to 16383. Okay, is a valid data. Whereby invalid data is less than 1. Okay, less than 1. And another, also another class will be more than 16, more than 16383. Okay, so these are the classes that you get the valid and invalid here. Okay, so one valid and two invalid. So for this product, okay, there are three equivalence classes. Okay, the class 1 is where the input or the data is less than one record, so it is invalid class. Okay, equivalence class 2, okay, will be from 1 to 16383 record, so this is a valid input. And equivalence class 3 will be more than 16383 record, so it will be invalid. Okay, so um okay, okay, so these are the test cases that you need to do. Okay, instead of you have to do for each value, okay, in each value, but now you only take one representative from each class. For example, for equivalence class 1, okay, which the record is less than 1. Okay, so this is the invalid class. Okay, the invalid class. You take one value from this class, which is 0. Okay, 0 is less than 1. Okay, so uh, 0 will be the representative, and the expected result, okay, should be invalid record. Right? Expected result. What do we expect? Okay, when 0 is the input. Okay, now for equivalence class 2, okay, where the record is greater than 1, greater and equal 1, and less and, okay, means that from 1 to 16383. So we know that this is the valid class. Okay, so you take one representative, okay, which is 10,987. Okay, so what do we expect? Okay, product found. Okay, and for the equivalence class 3, where the record is greater than 16383, so this is invalid group or invalid class. So you take one value, for example, 17,000, okay, which is greater than 16383. So what we expect is invalid record. So this is, okay, so we need here only three test cases. Okay, three test cases, which is 0, 10, 10,000 and 17,000. Okay, so the next we go to the boundary value analysis. Okay, the next approach is boundary value analysis, or BVA. Okay, um, large number of errors, okay, tend to occur at boundaries of the input domain. Okay, um, from our experience, okay, when we um, develop a program, okay, where you use array, for example, okay, sometimes the error happen at or occur at the boundary, okay, the boundary, example, at the your condition, okay, whether it is equal or less than equal or greater than and equal. Okay, so the it happened at the boundary. Okay, so BVA leads to selection of test cases that exercise the boundary values. Okay, and therefore it will complement the EPs now. Okay, because in equivalence partitioning we get the we get the data from inside the class. Okay, class of the classes that we already identify. Okay, but the BVA will focus or we take the value at the boundary. Okay, value at the boundary. Okay, so rather than select any element, okay, in the equivalence class just now, select in BVA it will select those at the edge of the class or the boundary of the class. Okay, for example, let's say the input condition. Okay, the input condition have a range from A to B. Means, for example, A is 100 and B is 300. Okay, from A to B. So from here we can create three partition, right? Okay, which is the EP just now, the valid range, the invalid range 1, and invalid range 2. Okay, so for valid range 1 is uh, okay, from 100 to 300. 300. Okay, so for this range, what is the boundary value? Okay, of course, 100, 100, and 300. Okay, the boundary value. Okay, for invalid range 1, which is less than 100, so the boundary value is 99. Okay, and for invalid range 2, okay, which is greater than 300, the boundary value will be 301. Okay, 301. So this, okay, will create, okay, we can create this test cases using the input values that sit at the border. So we can get, okay, 99 and 100, 300, and 301. Okay, which are all the boundary, okay, for the classes. Okay, so we get 4 test cases here. Yeah, which is when n, okay, the input is 99, 100, 300, and 301. Okay, so for your test cases, okay, to be filled in this table, okay, so you will test for these values, okay, 99 and, okay, 99. So if it is 99, so we know that it is less than 100, so it is invalid. Okay, so expected result is 100 invalid data. Okay, second boundary is 100. Okay, so it's valid. 300 valid. 301 it will be invalid record. Okay, so this is um, equivalence. Sorry, this is BVA. Okay, boundary value analysis, and we can see that how it complements the equivalence partitioning just now. Okay, so this is the strategy for black box testing. Okay, black box. Okay, because we want to see the input, we want to uh, uh, identify the input and what is the output. Okay, so the next will be white box testing. Okay, in next part will be white box testing, where we concern, okay, the tester will concern on the internal, okay, internal the coding of the program, okay, in the system.